Okay, so the next problem that we're going to do down here is number 5. So first we got to balance this. It's Fe2O3 plus CO gives you Fe plus CO2. So in balancing, we look at the first thing, and looking at it, we have 3 plus 1 oxygens over on the reactant side, and on the product side we only have 2. So the first thing we can do is balance our oxygen. So we put a 2 right here. Okay, I'm putting a 2 right there. Now we've changed the amount of carbons. So with carbons, now we've changed also our, well, we changed the carbons to 2, so over here we have to change our carbons to 2 as well. Okay, now this also changed our oxygen amount. So we've kind of put ourselves in a little bit of a predicament here because we're going to keep on going back and forth and changing one thing and then changing the next. So what we're going to do instead is kind of keep what we have, but let's look at something else. Let's look at our iron. So I have 2 irons. I have 1 iron over here. So I got to put a 2 right here. Okay, so now at least I balanced my irons. Now we can come back and look at the oxygen issue. So I have a total of 5 over here. So 3 plus 2 giving me 5. Over here I have 4. So it doesn't really solve my issue. So let's change this. Instead of a 2, let's put a 3 here. Okay, and putting a 3 right here, now what I have is 3 carbons, and then I have a total of 6 oxygens. So now over here, the only logical thing to do would be to put a 3 right there. So now I have 3 carbons. I have 2 times 3 oxygens, which makes 6, and I have 3 plus 3 giving me 6 as well. So now we're balanced. So you can kind of see how that problem for balancing could give you a little bit of a headache. Okay, so for this one, let's do number 5 here. So it says, if I have 13 grams of Fe2O3, how much will it require, or 13 grams of Fe2O3 will require how many grams of carbon monoxide to react completely? So you start by putting the number down that you're given, which is 13.0 grams of Fe2O3. So I do my times goes into, I want to drop grams down, grams of Fe2O3. Okay, and I'm going to then, this is my grams to moles conversion, and it's of the same compound, so Fe2O3. Now this is going to be 1 mole. The number that I would put down here is the molar mass of Fe2O3. Okay, so now iron has a molar mass of 55.85. So I'm going to do my molar mass calculation up here. So iron is 55.85, and then oxygen is 16.00. Okay, for iron I have 2 of them. For oxygen I have 3 of them. Okay, so what this equals out, 55.85, I'm going to use my calculator here, 55.85 times 2 is 111.7. And this is grams per mole. Okay, 16 times 3 is 48.0 grams per mole. So then I have to add those 2 numbers up. So 111.7 plus 48. And what I get is 159.7. And this is, of course, grams per 1 mole. Okay, so then I got to punch this back in over here. So it's 159.7 grams. Okay, so now I can cancel out my label right here. I'm left with moles of Fe2O3, but I need to get to grams of CO, grams of carbon monoxide. So I have to do another times, goes into, I drop my label down. Okay, and I'm going to moles of CO. Now the numbers here, this is my mole bridge conversion. The numbers I get here are from the coefficients up top. So anytime it's mole over mole, you want to look at your coefficients to get your numbers. So 3 for carbon monoxide, and then for Fe2O3 there's nothing there, so it's a 1. Okay, this cancels, this cancels. Now I have moles of carbon monoxide. Again, I want to get to grams, so I drop this label down. And I want to get to grams of carbon monoxide. So this is 1 mole. And then for carbon monoxide, the molar mass, carbon is 12.01, oxygen is 16. So 12 plus 16 is 28, and then you just add the 0.01. So 28.01. So now this is your setup. You guys do the math.